So today we'll be doing 2-1, which will be a factoring refresher. So we're going to start with topics that you've covered in Algebra 1 today and just review how to factor some things that you've already learned about. But I'm going to teach you as if you haven't learned because you haven't done it in a while. So let's get started. So the first most important thing you need to know about factoring is what we call the greatest common factor. So find the GCF of algebraic terms, and this involves finding the GCF for the coefficients and the variables. So there's two types of GCFs, coefficient and variable type. So the variable type deals with the degree, and the coefficient type deals with the number. So anytime that you're factoring using any method, you always first want to look for a GCF, okay? So we're going to just practice with the GCF today to get started for this slide. So what can I factor out of 12k minus 18? Nothing? We can take something out.
6.
Good. We can take out a 6, and that's because both 12 and 18 are divisible by 6, and that's the largest number that they're both divisible by. So we'll take out a 6, and we're left with what?
2k.
Good. 2k minus 3. Now, a way to check your work would be to use the distributive property and make sure you get what you started with when you do that. Does everybody see what I'm saying about checking your work? All right, let's go ahead and try the next one, which will be B. So what number is both 40 and 64 divisible by?
4.
Good. 4, they are both divisible by, but I think there's a bigger number we can take out, right?
8.
Good. You always want to take out the biggest one possible. So 8 can come out, and then you always want to look for the variable and see what variables they have in common. So they both have x's. Which one has the least number of x's? 64. And how many x's does it have?
4.
So you can only take out as many of that variable as the lower one has. So I can take out 4 x's. And how many y's can I take out? 1. So that leaves me with what? 5x to the what? 4th. And then plus, can somebody grab the door so I don't have to pause the video? And then that's going to be 64 divided by 8. Go ahead and grab a packet. Packet both of you will need. Yep, 8. Just 8, right? Because we already took out the 4 x's and the y. Right there, yep. Alright, is everyone good with that? How we got that? Alright, let's go ahead and try the next one. So here, what's the biggest number that I can divide each of these numbers by? 7. And what's the most m's that I can take out?
2.
Good. So that leaves me with what? 2 to the
4th
good minus
5
uh-huh
to the 1st
good minus 1. Thank you. So yes, you can only take out what the number of m's that the lowest one has, and since we took out a whole 7m squared, we only have a 1 left there. Okay, so don't forget about putting that 1 in. And the reason it's so important to remember is because if you were to distribute this back, it has to end up looking exactly like this. So if you didn't put the 1 there, you wouldn't end up with that term. So just be mindful of that. So let's go ahead and move into the next one. Is there any numerical GCF for D? No. Is there a variable GCF?
Yes.
What is it?
8.
Good, and B. What does that leave me with? 3b, right? Yep, there's 2 b's minus 5a plus 8. Does that make sense? So does anyone have any questions about that? Anyone have any questions about A through D? Are we good to move on to the next slide? Okay. So now we're going to talk about factor by grouping. So this is a method where you basically group into two sets. You factor the GCF out of each set, and then you rewrite using the common factor. Now when you use this method, you first always want to look for an overall GCF, and I'll talk about that when it comes up. So for the first one we're going to look at is going to be E. So factor by grouping, you actually put an imaginary line down the middle here, okay? Now what can I take out of the left side? What do you think? Yes?
Y.
Can't take out a y because they don't both have a y. But we can take out,
Yeah, we don't have a singular Y. Yeah.
no, you have to have, you can take out an x, very good. What number can we take out?
3.
They're not 32 and 4, what else?
8.
8, good. We can take out an 8, right? And an x. Which leaves me with what? Anyone? What's 32 divided by 8?
4 and 5.
Good. So 4y plus 5b. So everyone good with how I got that?
Yes.
Okay. Now over here, we can take out a what?
3,
Good. And in?
8.
Good. So we're actually going to take out a -3, and you're going to see why. -3a. And what that's going to do is it's going to change the sign of each term, which leaves me with what?
Positive 4.
Good. Good. Plus?
5B.
Good. So the reason that we did this is, what do you notice about these two?
Oh, that they're the same.
That they're the same. So I want you to treat what's in the parentheses like any other variable. If they both have a variable in common, what can I do with that variable?
Combine them.
Factor them out, right? So I can take out this whole entire thing. If you look at the sentence, I can take this out. 4y plus 5b. And then all I'm left with, if I take this out, is just the grouping of 8x minus 3a. So the way that it will always look in the end is whatever you got the same thing of will be one of them, and then whatever you have on the outside will be grouped together, and that's why it's called factor by grouping. Everyone see that, how that worked? Okay. Does anyone need a little more time on E? Okay. None? F. So for F, we're going to split it down the middle. What can I factor out of the left side? Good. What does that leave me with? 3x plus, good. What can I factor out of the right side?
5.
Good. And it's a positive 5, right? So when you do factor by grouping, you always put the sign in. You'll see why. And that leaves me with what?
2.
Good. So here's where you have to know your mathematical rules. Are these two the same exact thing?
Yeah.
Yes.
Because of what property?
Commutative.
Good. Because it's addition. It's the commutative property, which means these are the same exact thing. So therefore, I can factor this out because they're identical, right? So you can pick either form you like. Doesn't matter which one. 3x plus 2y, which leaves me with what left? X plus what? Good, x plus 5. Oh, that was just my typo. Thank you.
So I don't understand how I just get like
Why it can come out?
yeah, like how do we get it from the x
Uh-huh.
into 3x plus 2y?
Gotcha.
Where did that x go and everything?
So for letter G, before you move into any grouping, you first need to factor out a GCF if applicable. And do we have one here?
6.
I mean, 6 would have been nice, but I don't think it's going to be, 64 isn't divisible by 6. Anything else? They all have to be divisible by it.
4.
Not 4, because 18 is not divisible by 4.
8.
Think even lower than that, because 18 is not divisible by 8. 2, very good. So out of the entire thing, I can take out a 2. And that's the biggest thing I can take out of all the terms. Is everyone with me so far on that? I just divided everything by a 2. Now, this 2 on the outside is just going to kind of come along throughout the problem. Okay, we're not really working with it anymore. It's just kind of there on the outside, chilling on its own. Okay?
Factoring problems on the test, like the 9 weeks exam, the last 2 problems were factoring. Are those like, we expected to know how to do those, or?
We can look at it after I'm done with the video if you want. But yeah, I mean, yes. We did it in the first week of school. I took them from the first week pack. Okay. So what we're going to do here is now we're going to factor by grouping on this. So what can I take out of the first 2 terms here?
A.
And
3.
3a. Which leaves me with what? Thank you. What are we left with?
3
Mm-hmm.
minus 4y.
Good. And what can I take out over here?
8.
8b. Good. Which leaves me with 3 minus 4y. So does everyone see how we got that?
Okay, so we're going to do.
Now we can factor this out of those 2 terms, right? 2. And then we're left with whatever's on the outside. It's always whatever term they both have comes out, and whatever's on the outside gets grouped.
So how do you turn, I'm still kind of confused on, how do you turn both of those into just one of them?
It's not turning them into one of them. It's factoring it out of them. Just like I factored the z out of them. Let's go ahead and try the next one. What is the overall GCF for h? 10. We're going to take out a 10. Now, here's where factor by grouping has some limitations and you have to be careful. If I try to group the first 2 together, can I take anything out?
No.
So this is where rearranging comes into play. Does anyone have a proposal on how to rearrange these?
Yeah.
What do you think?
The third one and the second one switch.
Good.
Yeah.
Yep. So you can do it 2 ways. You could either do 4AD and then the 8 or the 3 and the 6 first. So we're going to go with the 3 and the 6 first. So you want to put them together in such a way that you can factor something out of each one. And if you do it in every combination and it still doesn't work, that's what we call a prime factor. It's prime, it can't be factored. But sometimes it can be factored, it just needs to be rearranged first. So does everybody see why we chose this arrangement? And it's commutative property, we can rearrange in math when it's addition. Or subtraction, just take the sign with you. So we're going to split it down the middle. What can we factor out of this first part here?
C.
Good, and a 3c, which leaves us with a plus what? 2b, right? And over here we can take out a what? And a bigger than a 2. Good. A 4d. Which leaves us with a plus what? 2b. We have a common factor of a plus 2b, which means we can take it out, right? So we got the 10 on the outside, we got the common factor that they have in common, and then we have whatever's on the outside.
3 plus 1.
Good. 3c.
Oh, yeah. 3.
Is everyone with me on that? Yes.
We always have to take a number out of 10 in the last one. We always have to, or will it still mess up?
If you say you didn't take it out and you started factor by grouping, you would end up with something here that would have to be factored out in this step. So you would have just done it later. Like you might end up with like 10a plus 20b, and then you can take out the 10 at that step. So if you forget it, it will still come up later. Anyone else have a question? Okay.
Oh, wait, I have a question.
Sure.
Do you want us to do like double parentheses, or should we do brackets?
I use brackets sometimes as well. I think in my last class, I just interchangeably use them. Either one is fine. Doesn't matter to me. Just don't use curly brackets because that means something else.
Yeah,
Alright, moving on. So now we're going to talk about factoring trinomials. So I have all these methods here because I know that you come from different backgrounds, different schools, different teachers, courses. You probably learn this different ways. So I'm going to go through each method, and then in the end, you pick which one is most suitable for you. Okay? I'm not going to ask you to do it a certain way. You just need to be able to recognize them. So we're going to specifically talk about factoring trinomials that have an a term of 1. So a little background before we do this. A trinomial's standard form is ax squared plus bx plus c. It has an x squared term, an x term, and a constant. Trinomials because there are 3 terms. The a is known as the leading coefficient, which is the coefficient of the x squared term when in standard form. What? Yeah. So notice here that we have a coefficient of 1. And this is when you can use these methods when that happens. So to do the box method, the first thing you look at is the coefficient. You're going to look for multiples of that number that add up to the coefficient of the x term, which is positive 2. So can you think of any 2 numbers that would multiply to give you negative 48, but would add up to negative 2? So what are some factors of negative 48? Negative 1 times 48, what else? 2 numbers that multiply to give you negative 48. Very good, 24 and negative 2. Any other ones?
Negative 6 and 8.
Very good, negative 6 and 8. That might be the one we're looking for, right? So you see this one here that Lex said right here, negative 6 and 8. Isn't it true that these 2 add up to positive 2? Those are the factors we want to choose because we want it to add up to that other term. So how you write this as your answer is you put 2 parentheses sets like this. The x goes here, the x goes here, and then minus 6 and plus 8. And it doesn't matter which one goes first because multiplication is commutative. Now we can use the box method to check our work. Does everyone remember how to do this? You multiply the corners. X squared, 8x, negative 6x, negative 48. You combine the ones right here because they're like terms, so we end up with x squared plus 2x minus 48. So do you see how these are equivalent, but one is factored and one is not? So I just want to kind of show you how they come back full circle there. So that's the answer. Anyone have any questions about that procedure process? Okay. Let's go ahead and try the next one. So this is a grouping method of doing this. You don't have to really use this method. I just want to show you how it kind of relates to the last one. What are some numbers that you can multiply together to give you negative 15 that will add up to 2? Oh, thank you. What do you think? Good. negative 3 times positive 5 would add up and give me positive 2, right? So let's say instead of writing 2a, can't we write 2a as positive 5a minus 3a? Isn't that the same thing as 2a? We could rewrite it that way, right? So I take this and I rewrite it in a different way. Now we could use factor by grouping. What can we factor out of the left side here?
An A.
Good, which leaves me with
5.
a plus 5. What can we take out of this side?
A negative 3.
Which leaves me with
A plus 5.
good, you're taking it out of the whole thing. Now you can do what we did before. You take out the a plus 5 and group together the a minus 3. So you don't have to use this method. I just want to show you how it relates to what we just learned, how it's the same thing. So see how you can simply just do it like we said earlier, products of this that add up to this and so on. Okay. So let's go ahead and try. Hello? Hi. Blue. Really? Nice. A little bit. Okay. Yeah, it's fine. You just have to have her, like, let her know to watch the video when I post it for the lesson. Alright? Yeah, and also she's got to come get her packet at some point. Or I can send her over one. Okay. You're welcome. Bye. Alright. Next. Let's go ahead and look at K. So, K is the X method. And this is just kind of another silly way of writing this out. Really, that's all it is. So, what you write here is A times C. In this case, it's just 1. So 1 times negative 10 is negative 10. And then your B term is negative 3. What are factors of negative 10 that add up to negative 3? Two numbers that multiply to give you negative 10, but add up to negative 3.
Negative 5 and positive 2.
Good job. Negative 5 and positive 2. That's what you write here on these two sides. And then your answer is just, in this case, n, not x. N minus 5 and n plus 2. And that's it. Okay. Ready for the next?
Can I copy the pen real quick?
Sure. Good. Good job. Negative 4 and negative 3 would be two numbers that multiply to a positive 12 but add up to a negative 7.
Oh, that sounds like something I would not be used to doing that.
Really?